because of that, hey guys, hey, this way. I'll try to make it so that they can leave and won't suffer too much. Will you go to page 294 and look at some antiderivative stuff? We're going to do this quickly.
294?
294. Bottom of the page, we've got the power rule. We looked at that. The next page, 295. Notice the constant one there. That one has given you guys trouble in derivatives. Okay? I would like not competition. Notice where that happens to that C. We could spend time with that, but notice what happens there. Okay? And then notice the sum. The integral of a sum is the sum of the integrals. The language is the same as limits and derivative. Okay? I can't have too much competition. Next page. And you find the trig ones. The first part is the derivative, the second part is the integral, or antiderivative. Notice how that A functions. Okay? 1, 2, 3, and 5 are the critical ones there. You should know. Not so much 5, but 1, 2, and 3. Know how those antis work. Page 297. There, look at 7, 8, 9. If I do some work with 9, I will probably give you some clues. But certainly know 7 and 8. Okay? Now you've done some work with that. And so let's get going on a number of things today. Okay, another thing. Up here, I have, this is differential calculus. Yes?
No.
Okay, this is differential calculus. And we did this limit idea of this secant. Are you with me here? Some of you are not watching? That secant becomes the tangent over here through this idea.
Yeah.
Okay, now we're going to do an area thing, and we're going to be talking about Riemann sums, and we're going to take all these little pieces as we're going along here. We'll break it up into parts, and the way we break it up into parts, we take the end point minus the front point and determine how many we want. And that's going to equal delta x, which is this distance in between here. Those are delta x. Okay? And now what's going to happen is that width is going to get shrunk down to 0, almost 0, not quite 0. Okay? And so this is integral, and you get the idea of area. And tomorrow, at the beginning, I'll give you some intuitive stuff to show you how that thing works. Okay? A few things about anti. You had to do a few of these kinds of problems for me, and this one goes pretty fast. Oopsie. I can't write on this screen. It doesn't work. F prime equals 2x minus 1. And I'm going to say f of 0 equals 2. I've said it 2 or 3 times. Okay? What's the antiderivative of this?
X squared minus 1 minus x squared minus plus c.
Okay, now, and yeah, Common, you were really ahead of everybody. And since, now this is a whole family of them, whole family of parabolas, an infinite number of them. But we've selected just one that's this one. So f of 0 is equal to 0 squared minus 0 plus c, which is also equal to 2. Okay? Now there's going to be plenty of times we're not going to put the 0 here. But it is kind of nice when we do. It works pretty slick. Okay? Now, with that in mind, I have worked up a problem, and working it is going to take a lot less time than writing the thing. And I wanted one that would be one we can do a lot of stuff with, and that's pretty friendly. Okay? Now, we know this situation. If I have a displacement function, s of t, what's its derivative equal to?
Oh, I know this one. Stop. Dang it.
V of t.
Okay? The derivative of displacement is the change in displacement is a velocity. Okay? And then also, what about this one? What is v prime at t equal to?
That's A of t.
A at t. Okay? Now, watch what happens here. If I do a double one here, like this, that's going to equal the first derivative of the velocity, which is A at t.
What is that again? Okay.
This is acceleration. This is velocity. Okay, now here's the problem. I wanted to go to the PAC building next door, but to make things work, I had to go a little higher than that to do my problem. And so I got up to the top, and I'm going to say that my displacement at 0 is going to be equal to 20 meters.
Did you throw something off the roof of the building?
Pardon?
Did you throw something off the roof?
Yeah, I'm going to throw something up off the edge of the building. Okay? And now over here is the building, and I'm going to throw something up, and it's going to come down, and over time we're going to show it to be this kind of a pattern. Okay? And this is the ground. Okay? Now, this height, I said, is going to be 20 meters. Okay? What's the acceleration due to gravity since I'm in a metric?
9.8.
Okay, to make life friendly and nice, we're going to say it's going to be 10 meters per second squared. Okay? Just to make things really work well. Okay, now I'm going to throw it up. Probably throw it out too, but my vector that I'm interested in is the one that goes up, and I'm going to throw it up at the velocity at the beginning. I'm going to throw it up at 15 meters per second. Now, you are going to be able to just write the Smt formula here from what I've got. Okay? So I'm going to start here. I know that A at t is equal to v prime at t, which is equal to 10 meters per second squared. From now on, I'm not going to use units anymore for the rest of this problem. Okay? If this is the case, what's v at t? Are you with me?
Yeah.
What's v at t? 10t plus c. Okay. Now, a comment was really fast a while ago in that v at 0 equals 15, so c is going to be equal to
15.
Okay, so now my formula is v at t equals 10t plus 15. I made a mistake along the way. This is acceleration due to gravity is down. Now it's throwing this thing up, so this is a negative, and that's a negative, and that's a negative. Okay, now I know also from up here that v prime at t equals, v at t equals s prime at t, which is this. This is s prime at t. Are you with me?
Right.
Okay, what is s at t now?
Negative.
Okay, and you've often wondered why that number is half. Well, now you see where it is. This is going to be t squared, right?
Yeah.
Okay, and plus 15 t plus c, but c is going to equal what? Because
20 is going to be 20.
s at 0 is 20, so I'm going to make this 20. Okay, now some of the problems are going to work. By the way, when you soccer guys go, and I'd like you to stay as long as you can, I'll flip the screen up and then you can see what the assignment is. It is online too, which is up to date. Tomorrow's assignment is wrong on the internet because I'll be changing it frequently during the course of this week. Okay, you see this? My question is, what's the maximum point here? How am I going to find that maximum point?
Plug it in there.
Oh, okay, just a second. Richard, your arm? Yeah. Derek.
To check.
How am I going to do it?
Graphic.
You graph.
Okay. Graphing is fine, but I'm not going to do that. I want to do it with
Critical points.
critical points. Okay. Now, hey, just a second. Critical points is great. Does someone have another way to do it? There is another way to do it. Pardon? I'll find the max, but we're going to find the max by looking at the critical points. Okay, I'm going to do that, but now something is going to happen that I could have. I'll show you the other one when we get to it. Okay, here. I'm going to take a -5 out here, like this, and you'll see why I wrote the problem. Isn't this cool?
That is brilliant.
Okay, now, that's nice, but that's really not the one I want at this point. I would like to, yes, go ahead.
Is this the one with critical points?
Now, this is critical points. I'm getting ahead of myself. To find the critical points here, I need S prime of t, right?
Yeah.
Yep.
And that's going to equal what?
V a t.
Oh, DeVries. DeVries says it's going to be this thing right up here. But we just didn't notice that. That's what you didn't notice a few minutes ago. So we're going to try to find this. Are you with me? That gives me 10t,
Negative 10.
negative 10t, plus 15. So the critical point is t equals
1.5.
3 halves, 1.5.
Why?
Why?
You solve for t.
0.
Because we wanted critical points and those are at 0. Okay? Got it?
Yep.
Now, we could do another one. Hey guys, listen, that's something you're going to be doing. We could have gone right up here and picked it up here. We already had it in development. Okay? Now, the next question is, when does it hit the ground?
0.
What zeros?
When A T equals.
When this equals 0. When this quantity equals 0, it's going to hit the ground.
Oh.
That's going to be right here. Right?
Yeah.
S of t is 0. Okay? Now, we can factor this into t minus 4 and t plus 1. So t is going to hit the ground at 4 and a minus 1. We throw this away because that's before time began. Okay?
That's cool.
Because that's actually back up here. Okay, got that? Okay. You're going to work a few problems like that. I hope I do have another one that at the end of the period, if we want to look at it, that you can do this. Okay? Here's the next thing we're going to do. Just a second. Okay. We're going to do this stuff right now. We're going to get started here. And I would like most of it done by calculators. Okay? Because otherwise this is so work intense, it's not even fun. Okay? You can do, we'll do a couple simple ones. Hey, okay, here. Now, here we go. So we'll see what happens. Here's a nice little function. It is very, very special. Lots of things come of it. And I would like to find the approximate area underneath that thing. And I'm going to go from 2 to 6. Okay? And I'd like to break it into intervals. And n stands for the number of intervals. And in this case, I'm going to make it 3 intervals. Okay? So, how wide is each interval?
4/3.
Oh no, let's make it 4. 4 of them.
Okay.
I want to make it easy.
One.
Now watch this stuff that I have here. This is going to be like an A, and this is going to be like a B. And so in this case, to get this, I'm going to go 6 minus 2 over 4, which equals 1, which equals delta x, which is the change in x.
Oh.
We're going to do a lot of stuff with this. I mean a lot of it at the beginning. Okay? Now, I would like to find the area now under here, making it into 3 intervals. And what I'm going to do is I'm going to use left. And what we're going to be doing is lefts, rights, and middles. And at the end, we're going to do it wherever. But that's going to be we'll have so many things at our disposal at that point, it will be difficult. Okay, we're doing the left side. That means we're going to take this point and we're looking up, and you can count how many are there. Now, what we're going to do, how high am I?
7.
Okay, now I'm going to put 1 here because it's very important in a minute. It's going to look foolish at the first problem, but it will be making more sense. Okay, now what's this one? Here's the height, right? Are you with me? And I already heard the word 8. 8 times 1. And we'll add this one. And
7.
okay, there's plus 7 times 1. And
6.
oopsie, where am I? I'm doing this side. Here we go. I got you. Okay, here we are. And that's another 6 times 1. Now, this is actually, I could take this one, and this. You notice they're all the same?
Yeah.
Okay, so I'm going to take it out. And then it's going to be 7 plus 8 plus 7 plus 6. Now, in this problem, it doesn't make any difference. And you can add that up.
1.
Now, that is, that's 20. Okay? Now, let's do another one. Which one do I have on my paper here? Just a second. I thought I was going to do a different kind of interval, and oh, that's cool. Let's do the same interval, and no, let's just go a different one. Let's go from 1 to 7, and I'm going to use n equals 3.
So they're going to
Okay. So what is, in this case, delta x?
2.
Are you all with me on that?
Yes.
No? Who said no? Okay. Because what we did here is this. This is 7 minus 1 divided by 3, which gives me 6 over 3, which is 2. Okay? Now, so we're going to look at this one, and now let's do it in the middle. Are you with me? In the middle. And so, this is my first grid mark from here to here, and here, and here. So this is one, here's another, and then here's another one here. Okay, the middle one here is right here, so I'm going to look at this. Now, how high am I?
7.
7 times 2 plus. And the middle one, oh, that's nice. Like this.
7
That's
times
a 7
2.
times 2 again. And the last one is 4 times 2. And so it's going to be 7 plus 7 plus 4 times 2.
Isn't that 4? Oh, okay. You took
Okay? What did you get? 36. Now, this is estimating, and now, guys, when you leave pretty soon, we're going to look at this one coming in a minute, and then we're going to get to some other very, very good stuff. Okay, the sheet is going to be just exactly like this. But it's good to have the right side up. And I still don't have it. Boy, how many times can I get it wrong? There we go. Okay. Now, I don't know if you can read this, but this says going from 1 to 7. So we're going to go from here to 7, and we're going to go in 3 intervals. And here's midpoint. So that's the kind of thing we did there. Here we're going to go from 4 to 9. And we're going to break it into 5, and we're going to use the right endpoints. Okay? So it's going to be like this. See that? Oops. Okay? And right endpoints. This is the right endpoint of that interval. And this is the right one here. Like that. Oopsie. And we're doing the right side here. It's like this. See how that goes? Yes.
Is there any, is the
Hey, please, quiet, please.
which one's more accurate? Like, is
Oh,
the left,
varies.
right, and the center?
Okay, it doesn't. It just varies on your function. It just gives you 3 different ones that we're going to look at. Yes?
So what is n is the number of bars that you're going to make? Or
Okay, now the question here is, what is this? Okay, and we do here 9 minus 4 divided by 5, and that gives me my delta x. And you see the delta x up there too. Okay, now this one, 3 and 4 and 4, and this one, okay, this one gives you something different. Derek?
What if from your endpoint, it's not right on a line?
It will be. That's why this thing's designed that way.
All right.
Okay? That's why I said it was special. It's made, and I really like the thing.
Okay.
So you're going to work this. I don't think it'll be very difficult. Okay? Now, here's the next one. And now technology is going to take part in this problem. Just a second here. What do I have? How do I want to do this? Okay. Now, okay. We're moving along okay. This is a curve which is x squared. And pretty soon I'll put the calculator up on the screen and we'll do some work with this. We're going to do the same kinds of things here. And now, the first time, correct. What, a right side or left side?
right.
Okay. He says the right side. So and we're only going to see this is 1 and this is a half. Let me just give you the middle values. What's the value? How high is this up? 1/4, right?
0.25.
Because the function is here. Okay. Now he says the right endpoint. So this is how we're going to approximate that, like this, and we're going to do it like this. Okay. Now I'll just how am I doing this here? My screen does not cooperate very well with me. So we'll just write it down here and we'll see what happens. Okay, so this is going to be, what's the size of this one? It's going to be 1/4 high times a half.
1/8.
Plus, it's going to be 1 times a half, right? And so this is going to be equal to 1/8.
5/8.
Plus.
5/8.
That's what.
Okay? Now, a while ago, we were asking which one is the most accurate. Well, this isn't terribly accurate. So as we're going along here now, I would like to break it into more intervals. Okay? You just gotta get the pattern. Okay? I'm going to break each of these in half again, like this. Are you with me on that? Okay, what's this height?
What is your n equal to here? Did I miss that?
This is n equals 4 in this one. Okay? So each one is going to be, delta x is going to be equal to 1/4. Okay? What's this height? 1/16. We got this one already. And this one is going to be 3/4.
No.
9/12.
9/16.
Okay? Are you with me? Okay. Now, developing this thing, so we can get this stuff. This height is going to be 1/16 times 1/4, right? And the next one is going to be 1/4 times 1/4. And the next one is going to be
9/16 times 1/4.
okay. And now, just a second here. We are doing right side, so we need one more up here, don't we?
Yeah.
We need that one too yet. And we need, see, we're getting that one, and this one, and this one. This one, this one, this one, and this one.
Yeah.
All right, you got 4 plus 1 times 1/4. Now, look what happens here, and this is a quick review, and we'll get to your book in a minute to show some things there. This is 1/16 plus 1/4 plus 9/16 plus 1, all times 1/4. Now I would like to show you these numbers here. This is 1/16 plus 4/16 plus 9/16 plus 16/16. Notice this progression. 1, 4, 9, 16. Okay? And now we're going to do that kind of stuff with our calculator in just a minute. And see, the idea, what we're going to try to do is get these intervals to be smaller and smaller and smaller. And we don't want it labor intense. This is labor intense yet. Okay? So now, I'm going to try to do this with my calculator. But why don't I take you through the calculator a minute, so what has to happen here. You notice this is a sequence. And that sequence is generated by x squared. Okay? And so what I'm going to do first, I'm going to use my calculator to do a sequence. And this is how it goes. In this case, oh yeah, okay, I'm all right. The first thing, I'm going to put my function in here like this. I just type that in. Then I put a comma, and my value that I'm using is x. I think you're aware enough of that sometimes this is necessary in computation because we're using the variable x, so that's there. And in this case, what's the first number I have here going up?
1/4.
1/4.
Can you put it up so you can see what you're writing?
Okay, and now it tells me where I'm going to stop. I'm going to stop here at this point. I'm going to stop at 1. And the next one is, how do I jump my steps? Are you with me?
By 1/4.
Okay, now pretty soon, I think I'm going to leave it this way. What do you think is going to come up on my screen? These numbers here are going to come up on my screen. Okay? So let's go and do that a minute. And you're going to find this very valuable, I think. And I hope it doesn't take us very long. Okay, now, I have this here. a sequence is under second stat, list, under list. Go to list, and then you go into the middle, and number 5 is sequence. Correct? Am I right?
Yeah.
Okay, and, okay, now, okay, we got 2 calculator kinds of things in working here. Some of you have the newest 84s, and but this emulator doesn't have that. So you hit sequence, and you have this. Okay? If you have that nice fancy thing, you just follow the instructions there. It'll give it to you. Okay, first put x squared, and then put comma x, and that's where you start.
Second step.
Okay?
Is ROC going out?
Not really.
Not right
No,
now.
no. Stick around a little bit longer yet. Then put this on your desk. Okay. See what we got
Yeah.
in terms of it. Now, oh, I did something different. I got to change this. My model on my notes here, I was going from 1 to 4. Don't pass them out yet.
Oh, no.
No. I would like to do what we did in the book. And let's go back here. Let's go back and put this back in like this. And now, what is our first number that we need here?
A 1/4.
Just a second.
Why do you want to put that in again? You want us to solve?
Because we went from 0 to 1. So my first number here is going to be, to come back 1 here. The first one we start with is where that's where we trip it to get started, and I'm going to put 0.25 there.
At 0?
Right there.
At 0.
First one, yes, for 25.
23 or 25?
5. Okay?
No, 0.25?
No. I have to slow down this emulator, it's so difficult. Okay, then comma, and we're going to stop at what point? 1. And I'll just move 1 further. And then it's a comma. And that's going to be, how fast are we going up from one to the other?
1/4.
So it's going to be 0.25 again.
And then another print.
And I think we stopped there, don't we? Okay, and now take a look at what it enters.
Whoops.
Okay? Now here are the numbers.
Yeah, I'll see if you want.
With me?
Come on.
Okay. Now, that's, yeah, you can't see them. That's one of the problems, and that's why I had to put the other one on my notes here to do. Okay, now, let me show you something next. What I want to do here is, now I would like my calculator just to add these numbers all up. It's going to generate these numbers here, all these numbers. And I'd like to add them all up for me like this. So I'm going to put a sum in front of it. See that?
Mm-hmm.
Then it remembers what I put in there and it adds them all up. Okay? And sum is under list and you go all the way to the end.
Oh, I found it. 5.
Okay?
Math.
It's 5 again. You got that?
And then we plug in our answer for that last part.
Yeah, I would get it this way first though. I would make certain you list it this way. Sum sequence this.
1.875.
1.875. Okay, now, when you go to math and type in fraction and enter.
Yeah, hold on, where's math? There it is. Math.
15
15/8, and that's what we had a while ago. Okay? Okay, I want to show you one other thing with this, and then we'll do a little practicing, yes. Okay? And that is, if I multiply this number now times my delta x, I'll have the sum.
What? But if you multiply the sum.
Okay, notice over here,
Oh.
I have to multiply by that. This here, what I'm doing, this part here, like this, gives me this part.
No,
Yes?
the 1/4 isn't in that.
This is 1/4 back here.
Yeah, but you squared the 1/4.
Oh, just a second. Yeah, right here. Yeah, okay. So you guys, well, hey, this is the assignment. Oh, you can pick that online. Okay?
Oh, yes.
Okay. Hey, this is where we had some problem last week too. Then all of a sudden we all turn off at this point. Now, I wanted you to get this down, and so let's go and look at part of the assignment which I want you to do. Up here, you're going to find some reading that's very important, and then on page 316, page 316, 316, look at problems 15 and 16. Okay? Now, it says there, and I'm going to read it so that I know what I want you to do. It says, use the figures to calculate the left and right Riemann sums. Okay? And you've got the function. The first one is a nice little line. And you notice it's going to go from 1 to 6, and it's 5. N equals 5. Okay? So you do those two manually.
15.
15.
I knew something was going wrong. Okay. Okay.
Which ones do you want to see?
Hey guys, listen. 15.
Yeah.
Now number 16.
Yeah.
Use that one and do that one with your calculator. In fact, do 15 with your calculator also to see that you get your answers correctly.
Is that on the side?
So do we use our manual?
Hey, listen to what I'm talking about. Any questions about those two?
Is this
What
part
or what?
of the assignment? Or just do it now?
Yes. No, this is later. Okay? Yes.
So we don't have to do it manually.
Do the 15 manually.
Okay, you do.
16, don't.
Yeah.
We don't need to at that point. Hopefully you know what you're doing. Okay?
Yeah.
Now, do we have something else besides soccer going on?
He was this soccer kid, he just forgot.
Okay. Okay. Now, on this page, go to page 317. Yes.
When do you want us to do 15 and 16?
Tomorrow.
So it's on the assignment.
Yes, absolutely.
But it's
Okay. Now,
But it's not on the assignment.
not on the assignment. that you
Okay,
did.
guys, I know this is hard to record right now. Just told us to do it, so just do it.
did you hear him? Now, page 317.
I don't wanna.
Problems 31, 32, and 33. We're not going to do all of them. You'll find out which ones I want you to do. Now, there's something there that I want to just review with you, which we've done before. It's summation notation. And I'm going to give you a sequence, which is 2 plus 4 plus 6 plus 8 plus 10. Okay, now, when you see this kind of stuff, we're going to put that in summation notation, but how many terms do I have?
Infinite.
You see that I have 5, but sometimes it's not that easy to see, okay? So the way we generate these terms, as I taught you before, a sub n, the nth term, this is the nth term, this is the first term, is equal to the first term plus n minus 1 differences. Remember that?
Yeah.
Okay, and the difference here is 2. Okay, now one of the problems is going to use this might be very helpful just to remember this one, okay, to find out how to generate the terms. This is summation, meaning there's a plus sign between all of those. We have done some of them. The book does a nice job of reviewing it, but it does go pretty fast. So check that out too, because we're going to be using this notation a lot, especially this week and the first part of probably next week. Because that sign is going to turn into this one, which is much more friendly. Okay? Much more friendly. But we need to work from here to get here. Okay? Now, yes?
So is, when it says use sigma notation, that's sum notation?
Yes.
Okay, so it's just a different one.
Okay? Now, you're looking at problem 31. Okay? This is so you don't get totally lost here. It says express these in sigma notation. And like the first one is like this. Here's sigma notation. And we're going to go, you can use any letter you want here. 1 to what?
5.
I think it's 5.
Yeah.
And what are you going to put here? N. Okay? And it's 1 plus 2 plus 3 plus 4 plus 5, period.
For what?
Now, would any of you like to start with a different number? If you do, that's fine.
H.
Oh,
So, like,
okay.
for B-
H is not a number.
So,
But I'm going to get you. I'm going to say H equals 2. Then where am I going to stop?
6?
7, I think. Oh no, 6. You're right. 6. And this is going to be N minus 1, or H minus 1. Okay. Why would you do that? I have no clue.
So, like, can you do C? Can you do part C of 31?
No, I'm not even going to go there. Okay. Now, that gives you a little thing with sigma notation. Now, oops. A few other things yet today. Let's see here. Just to get it straight,
Okay.
this sum sequence, do you have it plain in your mind?
No.
Let's spend just a couple of minutes with that up here, and then we'll call it quits. Yes.
When you enter it into your calculator, it's the function, comma, x, comma, the first number, comma, the last number, comma, what?
Okay.
Difference.
Now,
Mistake.
so we get this straight down. Let's just try it here a minute. We're going to go. We're just going to go. X squared is my function.
Yep.
And we're going to go from 1 to 10. And, shall we just go from 0 to 10 for now?
Yeah.
Maybe it's a little easier. 0 to 10. Okay, now, we're going to go sum, and then we have our sequence. And now the summing is of the sequence here, like this, and this is my function, this is here, that's all brainless. And now we're going to start breaking these into half intervals. So in other words, delta x equals a half. Okay? And we're going to start from
0.
0.
Oh, we're going to start from 0. Okay, so this is 0. What's my last number then?
10.
No, it is not.
9.5.
9.5.
What?
Because we're starting from this. See, that's why I wanted you to do this. This is going to stop at 9.5. It's clicking over every half. And we're doing, the last one starts at 9.5.
Okay.
Here we go. This is 10, and we're doing this interval right here.
Oh, okay.
And this is 9.5.
What if you did from the right interval?
Okay, that's going to be next, but let's finish this first. That's a very good question. Okay, now, how do I go from one to the next?
1.5.
Okay, that's 1/2, so 0.5 at this point. Now, we've done all the summing, and now I'm going to multiply by the widths. You see why I was doing that? That's times 0.5.
your
That will
sums.
give me the answer. Okay, now, the next thing over here.
Mr. Critter.
Yes.
So, do you plug that whole thing in first and then take your sum times 0.5?
Dries, stop. Say it once again.
Do you plug that whole thing in and then take your sum you get times 0.5?
Yes.
Okay.
That's at the end here.
So you would take like that 1.875 we got times 5.5 then?
I don't know.
Technically.
Okay, I didn't follow. Okay, now we're going to change this thing, and we're going to change it twice. Oh, we got enough time. We're going to go, instead of starting with 0, I'm going to start on the right side. Okay? And so this is going to be sum, sequence, x squared.
X, 0.5, 10.5.
Okay, and then we run it up to 10.
And so the outside number on the very right.
Say what's your